So we said we would go over the Bohr models on page 2 and 3. Okay, so here we have beryllium. So we need to look at the periodic table, and we're going to find beryllium. Beryllium's right here. It has an atomic number of 4. We're going to round the mass off to 9. So the symbol is Be. Atomic number is 4. We're rounding the mass off to 9. That means we know that it has 4 protons. The number of neutrons, 9 minus 4, is 5. The number of protons is always equal to the number of electrons, so that's 4. In the nucleus, we have 4 positive. We have 5 neutrons. And on the first energy level, we have 2 electrons. And when it's full, we go to the second energy level, and you can have up to 8. Our model only needs 2 more, so we're going to put 2 electrons there. These 2 valence electrons tells us it's in family 2. The 2 energy levels tells us it's on period 2. The 2 valence electrons are represented by 2 dots in this dot diagram. We're going to look for magnesium on the periodic table. Magnesium right here underneath beryllium, and it says it has an atomic number of 12, and it says 24.3. We're going to round that off to the nearest whole number, which is 24. We're going to put in our symbol Mg, atomic number of 12, mass 24, and the atomic number, we know that it has 12 protons. Find the neutrons, 24 minus 12 is 12. And the number of protons is always the same as the number of electrons, so that's going to be 12 also. That means we have 12 positive protons in the nucleus. We have 12 neutrons. We have 2 electrons on the first energy level. When it's full, we can go to the next energy level, which has up to 8. Now, we have 2 plus 8 is 10. Look here, you see that this energy level can hold up to 8 more at this point. We only need 2. We're going to put in these 2 electrons here. 2 valence electrons tells us it's in family 2. These 3 energy levels tell us it's on period 3. And we have 2 dots in the dot diagram to represent these 2 valence electrons. Calcium, we're going to look at the periodic table, and right here, there it is. The 3 elements were right in a row: beryllium, magnesium, and calcium. So we're going to see that calcium is Ca. Okay. And when we look at the periodic table, it has an atomic number of 20 and a mass of 40. Put an atomic number of 20 and a mass of 40. Okay. Well, we know from the atomic number that the number of protons is 20. To find the neutrons, we take the atomic mass of 40 minus 20, and that tells us there's 20 neutrons, and the number of electrons is always equal to the number of protons, because the atom is neutral. So in line with this, we have 20 protons, we have 20 neutrons, we have 2 electrons on the first energy level, and we have 8 on the second energy level, we have 8 more on the third energy level, and 2 plus 8 is 10, plus 8 is 18, plus 2 more is 20. So the model is complete. We have 2 valence electrons here, so that tells us it's in family 2. We have 4 energy levels, so that tells us it's on period 4. And our diagram, so we have 2 dots in it to represent these 2 valence electrons. What do all of these models have in common? Let's see our choice. 1, 2, 4, Okay. They all have 2 valence electrons. Can you see a pattern of their location on the periodic table? They're all right here. Beryllium, magnesium, calcium, they're all right here in family 2. This is 2A. Let's look. They're all in the same family. What is the pattern? The number of valence electrons is the same as the family. That was true. 2 valence electrons, family 2. And the energy level is the same as the period. And that's true. You had 4 energy levels, and it's in period 4. Yeah, it looks like we did this right. The only thing we would need to do is check to see if our Bohr models are right. Okay. On this next page, we're going to repeat the process. We have the electron pattern here. We're going to look to find oxygen on the periodic table. Oxygen is over here in family 6A. And I want to make this a little smaller. I want you to notice that the families that we're dealing with, family 1A, 2A, and then these are all B families. And we're over here, family 3A, 4A, 5A, 6A, 7A, 8A. So these are our family members that we're dealing with. Family 1, family 2, family 3, family 4, family 5, family 6, family 7, and family 8. And we're looking for oxygen. So here it is. It says oxygen has an atomic number of 8, and it has a mass of 15.9994. So we're going to round that up to 16. So we have an atomic number of 8, and a mass of 16, and we have an element symbol of O, and we know from the atomic number that we have 8 protons. The mass of 16 minus 8 is 8 neutrons. That means we also have 8 electrons because we have 8 protons. So in our nucleus, we have the 8 protons. And we have the 8 neutrons. And then on this first energy level, it can handle up to 2 electrons. We need to get to a total of 8, so we look to the second energy level, which can hold up to 8. We're only trying to get to 8, and we only have 2, so that means we just need 6 more. 6 valence electrons tell us that this thing is in family 6. 2 energy levels tell us that oxygen is on period 2. We have 6 valence electrons. That's represented by 6 dots in the dot diagram. It's done. Okay. Now we want to find sulfur. Look at the periodic table. You're going to see sulfur is right here under oxygen in the same family. It has an atomic number of 16 and a mass of 32. And here, our symbol is S. And then we have an atomic number of 16 and a mass of 32. We know that the number of protons equals the atomic number is 16. To find the neutrons, we take 32 minus 16, and it's also 16. And we have 6 electrons, 16 electrons, because atoms neutral, so it's the same as the protons. And we have 16 protons in the nucleus. We have 16 neutrons in the nucleus. We have 2 electrons on that first energy level. And we know that the next energy level can hold up 8 electrons. We're going to put them right there. And we're trying to get to a total of 16. Right now we have 2 plus 8 is 10. And the third energy level can hold up to 8 right now. So we're going to put the other 6 that we need right there because we still have room. 2 plus 8 is 10, plus 6 is 16, so the model is complete. We have 6 valence electrons. We know it is in family 6. The model has 3 energy levels, so it should be on period 3. Family 6 means 6 balanced electrons means there are 6 dots in the dot diagram. Looks complete. Let's look for selenium. Well, selenium's right here in the same family. Now let's notice that oxygen is on period 2, which over here we said it should be on period 2. And we said sulfur was on period 3. Sulfur is on period 3. Now we're looking at selenium. Okay, so it has an atomic number 34. And this is 78.9, so we're going to round that to 79. And the symbol is Se. Here the symbol is Se. And if you forget, you can just look back here again. Selenium is 34 and 79. Okay. And the number of protons is going to be 34. Okay. To find the number of neutrons, we're going to take 79 minus 34. It's okay to use a calculator. 79 minus 34. 45 neutrons. Oops. 4, 45. And you know the number of electrons is always equal to the number of protons. And our nucleus is going to go with 34 protons. And we have 45 neutrons in the nucleus. We have 2 electrons on this first energy level. And then we have 8. And then we know the third energy level can hold up to 8. And remember, we're reading this across. It's like you would read the words on a line. So we're going to go 2, 8, 8, 2. And get out there to the end. Now, we need 34 electrons. We have 2 plus 8 is 10. Plus 2 plus 8 is 10. So that's 20. And we remember that we can go back to this third energy level, and 10 more can be here. So we're going to put them right there underneath the 8. Okay, and look up here, see? Right underneath the 8. And that's right where we put them. So we have 2 plus 8 is 10. Plus 8 plus 2 is 10 more, that's 20. This is 30. We're trying to get to 34. After this 10, we go to this 6. Look, it has a bucket that can hold up to 6. We only need 4 more. Now we have 2 plus 4 is 6 balanced electrons. This should be family 6. We have 1, 2, 3, 4 energy levels. So we'll put down 3 at 4. Now let's go ahead and put the dots on the dot diagram. So it should have 6 dots to represent those 6 balanced electrons. Okay, and this looks like it's done. Okay, well, all these models have in common, they all have 6 balanced electrons. What is their pattern in the location on the periodic table? They're all in the same family. Let's look over here. All in family 6. Families go up and down. There's oxygen, sulfur, and selenium. Okay. What is the name of the electron located on its outside energy level? So many times I said balanced electron. What is the pattern in the number of balanced electrons have in common? The number of balanced electrons is the same as the family, and the energy levels is the same as the period. And it looks like we did this right. The only thing that we would need to do is check these Bohr Model pictures. I can assure you that they're correct. If we check on this, we can look, and it would take us to a link to selenium. And you will see that the dot diagram has 6 dots in it, just like what we put in our model. Now, we're going to carry on and finish up this packet, and then we're going to come back next time and take a look at the last models.